Alright, we're going to take a look at another quadratic form equation that's a little bit different than some of the ones you may have seen in class, but the idea is very similar. So here we have x to the minus 2 plus 5x to the minus 1 plus 6 is equal to 0. So we're going to make a note over here that if we do x to the minus 1 times x to the minus 1, when we multiply like bases, we're going to go ahead and add the exponents. So it'll be x to the minus 1 plus minus 1, or x to the minus 2. So that's a lot like x times x is x squared, so the factoring is going to be very similar. So we're going to need an x minus 1, and then on each factor, so an x minus 1 and an x minus 1. Then we need a product of 6 and a sum of 5, so that's going to be 2 and 3. Okay, so x to the minus 1 plus 2, x to the minus 1 plus 3 equals to 0. We're going to set each one of those equal to 0. So x to the negative 1 plus 2 equals 0. We're going to subtract 2 from both sides. And then the other one we're going to subtract 3 from both sides. Now we're going to make a note that b to the minus n is defined to be 1 over b to the n. So x to the minus 1 just sends the x down into the denominator, so that'll be 1 over x is equal to minus 2. Same thing with the other equation. 1 over x is equal to negative 3. We're going to go ahead and clear the fractions. The LCM of both equations is just x, so we're going to multiply both sides by x. And on the left side, on both equations, the x are going to absorb. So 1 is equal to negative 2x. And 1 is equal to negative 3x. And to divide both sides by negative 2 and get x is equal to minus 1/2. Or divide both sides by negative 3. And 1 is equal to negative 3. Okay? So that's just doing regular old factoring. Now we can do the same thing with u substitution, but what I said in class is not true for negative exponents. So I said to always go with the smaller exponent. So in this case, the smaller exponent is negative 2, but we don't want to do that. We want to go with the biggest positive number. So it depends on the sign of the exponent. So if we wanted to be a little bit more careful, we would say the smallest exponent in terms of the absolute value. So if we took the absolute value of minus 1, that's 1. The absolute value of minus 2 is 2. So we would want to let our u, or put our u to be the smaller exponents in terms of absolute value, which would be the x minus 1. So we're going to put u equals x to the minus 1. So then when we take your square, we're going to square both sides. And when we have an exponent raised to an exponent, we multiply them. So negative 1 times 2 is negative 2. Okay? So now the x to the minus 2 is going to become u squared plus 5. The x to the minus 1 becomes u plus 6 equals to 0. This is a nice factoring problem. Factors into u plus 5. I'm sorry, not u plus 5. U plus 2 and u plus 3 equals to 0. Solving both of those, u equals negative 2, or u is equal to negative 3. Now, we weren't interested in solving for the letter u, we were interested in solving for the letter x, so u was x to the minus 1. And we'll go ahead and replace, and now it's procedurally identical to what we did when we just did regular old factoring. So it can be argued that maybe u substitution is a little bit easier here, but you can certainly do just regular factoring also. So it's kind of a matter of preference. Kind of how you think, but ultimately it would be kind of nice to be able to do it both ways, because sometimes it is a little bit cleaner to do u substitution, a little bit less writing.